Hi guys, welcome back to In Case of Econ Struggles. Today we've got another micro struggle for you. We're talking about the profit maximization problem, the producer problem. This is still under the topic of consumer choice theory. Remember to like and subscribe so you keep up with all of our videos as we post them, and make sure to comment below if there is a topic or a video you'd like to see. Let's talk about what we're going to do today with regards to the profit maximization problem. First, we are going to set up the profit maximization problem. We are going to talk intuitively about the problem and the setup. Then we are going to start deriving what's called the profit function. We are going to be careful. We're going to take our time and really make sure we understand what the profit function entails. We're going to talk about the assumptions we make along the way as well. Then we are going to talk about an intuitive solution of the profit maximization problem. We'll use that to find the graphical solution to the profit maximization problem. And then finally, we will get even more into the math and talk about the analytical solution to the profit maximization problem. And in doing so, hopefully we will really hammer out why the answer to the profit maximization problem is marginal revenue equals marginal cost. So keep that in mind as we go through the video. Again, these timestamps will be below in the description. So if you'd like to skip around, if you want to watch a section of this video again, feel free. And without further ado, let's start talking about the profit maximization problem. So the way we are going to start is we are going to pretend that we own an ice cream store. So here's our little shop. And we are trying to decide how many ice cream cones we want to make today. So we sell ice cream cones only. It's our first simplifying assumption. There is no milkshake, no sort of fancy sundaes. We're only selling ice cream cones. And we're also going to make it a little simpler by simplifying how exactly we're making this ice cream. So we are going to say that we have a wall of machines, and we are going to have workers who work those machines, who make those ice creams, and who take orders from customers. In other econ classes, you may hear machines referred to as capital. You may have workers referred to as labor. Either one, whichever makes it easier for you, but we are using machines and workers to make our ice cream cones. We are also going to assume that we've locked in, it's a Monday, we cannot hire or fire workers, we can't have someone install or uninstall ice cream machines. The only thing that we can decide today is the number of ice cream cones that we are going to make. Some professors may refer to this as Y for output, some may refer to it as Q. But when you see these symbols, we're just thinking Y, Q, it's the number of ice cream cones that we are deciding to make today. Unsurprisingly, we are trying to maximize the amount of money we're making. We're a business, we are trying to maximize profit. We are not trying to maximize our revenue. Revenue being how many ice cream cones we sell, how much money we make before we paid our workers, before we paid for the cost of our machines. We are trying to maximize profit. Now, profit is generally represented by the Greek letter pi. When we see pi, we should be thinking profit. Now, let's derive the profit function. Let's talk about the profit function. So we're going to derive profit, which hopefully will make intuitive sense, but we're going to go over it just to make sure it's clear. Profit, very simply, very conceptually, is the money that I make minus the money that I spend. So the money I make, that is based on how many ice creams I sell, and the money I spend, again, that's the wage I'm paying my workers. That's the electricity bill I need to pay to keep my machines running. The bills I pay for the air conditioning in my shop, all of those sorts of items are the money I spend, and we call those costs. The money I make from selling ice cream, we call that revenue. So profit, very simply, is revenue minus cost. To continue with this problem, let's put some numbers. Let's think more concretely with an example about the profit function. So let's suppose that ice cream sells for $10. meaning every customer who walks up to your store and orders an ice cream cone, when they are checking out, the cashier will ask them for $10. That is the price they are paying for the ice cream. This comes from our first large assumption that we are in a perfectly competitive market. That means imagine there are 100 or more small ice cream shops in this town where we are operating. We are selling our ice cream for $10. If I tried to raise my price to $11, absolutely no one would buy ice cream from me because I am higher than every other ice cream shop in the city. And if I tried to sell my ice cream for $9, then everyone in the entire town would come to my store to buy ice cream, and I would quickly run out of ice cream because we are in a perfectly competitive market and all ice creams are the same in this town. We all make the same exact type of ice cream cone that is called a commodity. So let's say costs, talk about our cost function. So C of Y, where again, Y is the number of ice creams that we are selling, the number of ice cream cones. And let's just make that equal to the number of ice cream cones I sell squared plus 5. Now, we are going to cover types of costs. We're going to dig in more into the different types of cost functions in another video. But for now, the main points here, this is what we call a fixed cost. So imagine we need to pay the city to operate our ice cream store in the city. Maybe we have to pay $5 for that licensing fee. So our fixed cost is $5. That does not depend on how many ice cream cones we sell today. Now, this Y squared, this does change with the number of ice cream cones we sell. So we call this a variable cost. It varies with our level of output. So if I sell more ice creams, my variable costs go up. And this is a parabola, which will look something like this. So our costs get higher and higher the more ice cream we sell, which is something we want to be aware of. Now, let's think about the intuitive solution to this problem. Let's think about it with some numbers. So here I've drawn up a quick table where we have the number of ice cream cones that we can choose to make and sell today. We've got the associated revenue with that, the associated cost, and then profit, which is just revenue minus cost. Notice that if we sell 0 ice creams, we make 0 in revenue, but we still have to pay that fixed cost, that licensing fee to the city. So our revenue today is -5 and we're losing money, which is not ideal in a profit maximization problem. Then as we sell more and more ice cream, our profit goes up. And then at some point, our costs get higher and we start having decreasing profit, or our profit starts to go down. So looking at this table, we can see that our best option, our highest profit, our profit maximization point, is 5 ice creams. Notice, again, we're maximizing profit, not revenue. Maximizing revenue, we would produce as many ice cream cones as we can, but we would not necessarily maximize profit. Let's talk about this graphically. So here I've drawn this profit function. How did I get this profit function? Well, I said from before, profit is $10 per ice cream times the number of ice creams that I sell minus the cost. The cost is y squared plus 5, which gives me the equation 10y minus y squared minus 5, which is an upside down parabola, and it hits its maximum point at 5. As we saw before, on this side of 5, our profit is going up, and after 5, our profit starts going down. So here's profit goes down, and here is profit going up. And we can see here, again, profit here is +9, +7, +5, +3, and +1. And then on the other side of 5, we have -1 and -3. Let's think more about how we can characterize or talk about or describe the point at which we have our profit maximum. So we can add 2 little subcategories here, MR and MC. Marginal revenue, or MR, is equal to the extra revenue that I get when I sell 1 additional ice cream. So because the price is 10, if I sell 1 additional ice cream, my marginal revenue is equal to 10. This is also the derivative of revenue, because in Econ, when you hear marginal, you should instantly start thinking about derivatives. So like I said, it's $10 per ice cream, which we can see from the table, every extra ice cream I sell, I get $10 extra in revenue. Now let's talk about marginal cost. Marginal cost, very similarly, is the extra cost I incur from selling one additional unit or one additional ice cream cone. So here, our marginal cost, similar to marginal revenue, is going to be the derivative with respect to output of cost, which is equal to 2y. So we can see here that it is 1, 3, 5, 7, 9, 11, and 13. Notice that at that profit maximizing point, we have marginal revenue is very, very close to marginal cost. That is because it's not equal due to the fact that this is just a relatively simple example and we're dealing with whole numbers, where when we generally talk about calculus, calculus is an instantaneous rate of change, and here we're doing an integer rate of change. So it's not going to be exactly the same, but hopefully this makes intuitive sense that at the profit maximizing point, marginal revenue equals marginal cost. And we can see that if we draw the graph, because if we put in marginal cost here, we are going to get something that looks like this, because marginal cost is 2y. So here's marginal cost. And then let me back up. Let's back up. Here is marginal revenue is up here at 10. Let's put this on a different graph. This is confusing. Let's put this on a different graph. Here is y again. Here's dollars. Here's 10. Here's marginal revenue, because we said it's 10 per ice cream. Here is marginal cost. And we see here where marginal cost is equal to 10, we are selling 5 ice cream cones. So it makes graphical sense as well that our profit maximizing point is marginal revenue equals marginal cost. So that if you take anything away from this video, take away that profit max means or implies, this is an arrow, implies that marginal revenue equals marginal cost. In other videos, we'll explore other ways to see that marginal revenue equals marginal cost. But for this simple example, hopefully it will be relatively clear. Let's do an analytical solution now. So let's do an analytical solution with our same numbers. So I'm going to say marginal revenue equals marginal cost. Marginal revenue is 10. Marginal cost, remember that cost of y is y squared plus 5. Let's make that a little easier to read. Y squared plus 5. The derivative of this is 2y, so y equals 5. So this is how many ice cream cones I should make. If I wanted to know what the profit of that is, well, the profit of 5 is just my revenue minus my costs. So this is 50 and this is 30. So my profit maximizing point is selling 5 ice cream cones. How much profit do I get from that? I get $20 in profit. Again, make sure to like and subscribe, comment if you have questions or found something difficult, and we will see you for the next video of In Case of Econ Struggles.